Alright, welcome. My name is Kome. Welcome to this day 10 of the 30-day challenge on functional programming. So the first task that we are having here is to partition arrays based on a predicate. So you can see here you have an array that we receive as the input here to this function as a parameter, and then there is a predicate or the function that will be able to pass each of the array elements to this predicate function and either return true or false and then group based on that. So the first thing you can see here, for example, you are grouping based on the even numbers, and then the other one we are grouping the other in another bucket maybe that didn't pass the predicate. So let's see how we'll achieve that. So I'll make use of the reduce array method, and then inside here I'll pass in the passing. I will pass in the passing, accumulator with passing, and then the filling. And then of course that will be the accumulator, and then I'll pass in the item itself. So inside here, inside this callback, I will run the predicate and then push items to the arrays as would be required. So here, if I happen to get, then the initial array will be, the initial accumulator value will be two empty arrays, the passing and the failing. So let's get then into the callback and see what we'll do there. So inside here, I'll come and first of all check for the predicate. If the predicate passes the predicate, if this item happens to meet the predicate or pass the predicate, then I'll come and do this for the first part of the array, the passing. Then I'll come and spread the passing, and then of course I'll merge that with the item itself, and then return the failing to return the accumulator. So if that happens to be false, then the predicate item didn't pass, then of course we'll come here, the first array will return the passing, and then the second array will return the failing. We'll spread the failing, and then we'll merge it with our item. So remember here, when we spread, we create new arrays, therefore they become immutable. We are able to pass maybe the functional programming principle that calls for immutability. So we are able to create new arrays and then act on those new arrays every other time by using the spread here. So I'll run this, and I can see there's an error because I didn't put the bracket there. So I'll run again, moving to level 2. So here you have to partition objects by property threshold. So again, the same logic here. Remember here, we could be having an example where maybe you are partitioning student by their marks. Maybe if we could be calling maybe the graduates and the ones that won't graduate based on a threshold. Also, you could have items, grouping items maybe from the shopping list as either, or an e-commerce application as either expensive or cheap based on a certain threshold. So here we'll call the reduce again array method, and then here we'll partition based on the property threshold. So here again we will say maybe above and below the threshold, and then inside here we'll pass in the item itself, and then the callback, and then the accumulator will be initialized to two empty arrays, or the two empty buckets that we will store our values. So inside here, send the callback, then we'll come and check. Now, is item key, or the item itself, is it greater than or equals to? Is it greater than or equals to threshold? Threshold. If it happens to be true, then we'll come again and spread the first value, which was the and then merge it with the current item. With the current item, and then adding the below. Otherwise, if it happens to be false, we'll come here and return the above as it were, and then come and the second parameter, or the second array, we'll spread the below to create a new array altogether and act on it, and then return the item as like that. So I think this one will work, and then of course we don't forget the bracket there. Good, moving to level 3. Now, here we are having to multi-way partition with multiple predicates. For example, here you could be having a list of, let's say, customers, and then we want to group them as as them being either active. If they have logged in the last, maybe let's say 10 minutes, we'll say they are active. If they have logged in the last 20 or 30 minutes, you could say they are idle. And if maybe they logged in the last 3-4 hours, we'll say that is churn risk. And then you can group maybe the others as others, those ones who of course logged in maybe last month or the month before. So let's look at how we'll achieve this. So the first thing here is for us to be able to create the buckets that will be storing our arrays based on the predicates. So the predicates, if these functions are, let's say 5, we want to be able to have 5 arrays. And then of course we'll have another array that will store indicates that is not in the predicate. So to achieve that, then we'll say const, then we'll call them buckets. Then inside here, can make use of the array from, which takes in the length. The length will be equals to the predicates dot length, and then +1. And the map function. And then inside this map function, we want just to return an empty array. So we'll have arrays or buckets equal to the size of predicates +1 to store all these categories. So having done that, then the next thing would be for me to come here and loop through maybe this array. So I'll say array dot I'll call the reduce function here. So inside here, of course, we can have the accumulator, and then we have the item, the array item. So of course, this one will be, of course, I want to return this here. I want to return the result here. So inside here, inside this callback, we'll do all the logic, and then of course, we must initialize our reduce to, or our accumulator for the reduce to the first time we have buckets that are equal to the number of predicate functions and then one extra. So having done that, then I'll come here and of course look for the index. So I'll say const index. I look for the index among the predicates, because every predicate will have, of course, it's an array of predicates. So I want to find the index that passes the element, the first element or the first match. So I'll say array index, and then of course I'll have the function here, or the function, and then of course I'll return only the one that this item returns through being the first one. So here the find index here, you rather return the index of the predicate if this item was successfully executed by the predicate. Otherwise, if it was false, you will return -1. So this one will help us, this index will help us know where to place this item on the bucket list. Remember, the bucket list is equal to the number of predicate functions and then one extra. That is the one that will not meet that will not be among, or will not meet the requirements of any of the predicates or any of the functions. So here, then you can return our bucket list. Sorry for that. So here, just a minute. So here you can have a bucket index. You can return a bucket index that will be equals to. So here we can come and check if the index if the index, if the index happens to be equals to -1, if it is equals to -1, then of course we want to push that to the last element of the array, of the bucket. So we'll say predicate dot length to the last index, that is predicate dot length, or predicates dot length, sorry. Otherwise, we want to push it to the index that we have returned here. So now we'll come inside again here. Remember, you want to create something that is immutable. Therefore, you cannot just make use of the push alone, because push will mutate the element. So what we will do here is that we will go through we will return the accumulator. You go through the accumulator and map. And then of course, we want to map through all the buckets. And then of course, we have their indexes. So here, we'll come and check, we'll come and return, we'll come and sprint, we'll come and check, is the index that we have here equals to bucket index. If it happens to be true, then we'll come and sprint the bucket items, and then of course push our item there. Otherwise, we'll just return the bucket as it was without any alterations or without any additions. So I think that one should work. Let's see. I'll run it. Missing after the argument list. Good. So here we should have this. So I'll run. Bucket is not defined. Bucket is not defined. So here you have bucket.map bucket, sorry. So I'll run again. Good. So we cleared all the challenges. I hope you learned a lot. See you in day 11. And please, if this made you learn something, please follow me on Twitter at ComeKelvinK. And also, don't forget to like my YouTube channel. And also, comment on the YouTube comments so that I can know if you are ready for my upcoming functional programming book. Thank you so much.